Okay, so multiplying and dividing surds. The good thing about that is it doesn't matter whether the surds are the same. We just multiply the numbers as we normally would. So it's not unlike when we add and subtract fractions, the denominator needs to be same, but if we're multiplying and dividing, it doesn't. Same with surds, okay? So root 3 times root 12. Now, the order in which we simplify is up to you. 3 12s are 36, so that's the same as the square root of 36, and the square root of 36 is 6. I could, in this case, simplify root 12 first by writing it as root 3 times root 4. Okay, so the square root of 4 is 2. That leaves me with a root 3 times root 3, which is root 9, which is 3, and 2 times 3 is 6. So it'll simplify, it doesn't matter which order we do it, okay? Just so long as you evaluate the expressions correctly. Root 8 times root 18, again, I could do 8 18s. It'll be big off the top of my head, so instead I've decided to simplify each one first. The square root of 8 is root 4, which is 2, times root 2. The square root of 18 is the square root of 9 times the square root of 2, which is 3 root 2. When we multiply numbers, we can use any order. So 2 by 3 is 6. Root 2 times root 2 is root 4. So we end up with 6 times 2, which is 12. These ones are small enough, so we might just multiply them straight away. 6 2s are 12. Root 3 by root 3 is root 9, and the square root of 9 is 3. 12 3s are 36. Again, what have I decided? I've decided to simplify. I could have done root 3 by root 12 by root 8. It gets a bit big. So instead, I've got 3 root 3, so I've left that. Root 12 is root 4 times root 3, and the square root of 4 is 2. So it gives me a 2 root 3. And root 8 is again root 4 times root 2, which leaves me with a 2 root 2. And now they're a bit smaller, so I can make multiplying a little bit easier. Multiply the numbers first. 3 times 2 times 2 is 12. And then if I multiply the surds, root 3 by root 3, which is root 9, times root 2. And so instead of putting root 18, I left it at root 9 because I know the square root of 9 is 3. 12 3s are 36, and I've still got the root 2 sign there. 13, 12, and 18, again, I could just multiply them all, but it works best if we simplify the surds first. Square root of 13, well, 13 is prime, it's not going anywhere. Square root of 12 is root 4 by root 3, so the square root of 4 is 2. And the square root of 18 is root 9 by root 2, and the square root of 9 is 3. Multiply my whole numbers together, I get 2 3s are 6. Then I get 13 times 3 times 2, which is 13 times 6, which is 78. And I gave it a quick bit of thinking. I couldn't think of anything that the square root of 78 simplifies down to, so I left it at that. Dividing surds is similar. Okay, so we can divide any of the numbers that are under the radical sign. So in this case, I can do 12 over 3, all inside the square root sign, and 12 divided by 3 is 4. Square root of 4 is 2. So that one works out quite nicely. When we have, I guess, a lot of the time, it actually is easier to write it as a division symbol. So if I go back to example run, I could write it as the square root of 12 over 3, which is the square root of 4, which is 2. Yeah. So often we probably approach it that way. So 6 root 8 divided by 2 root 18 is 6 root 8 divided by or over 2 root 18. When we have a fraction, we simplify top and bottom. So 6 over 2 is 3, so that's where that comes from. The square root of 8 over the square root of 18. Well, if I divide both of those by 2 to simplify, I get the square root of 4 over 9. And the square root of 4 is 2. Wrong one. The square root of 4 is 2. And the square root of 9 is 3. So 3 times 2 over 3 is 6 over 3, which gives me 2. Okay, there's other ways you could approach it. Similarly here, 6 over 2 is 3, and root 8 over root 2 is root 4. and the square root of 4 is 2, so I get 3 2s are 6. Now we can do our normal simplification when we're multiplying fractions in terms of top and bottom. So I could have, as we look at it, I could have cancelled those two terms and got 3 root 8 over root 2, okay? So I could have gone that way, so then I would have had 3 root 8 over root 2, which is 3 root 4, which is just 6, same answer. Instead, I thought, well, let's just multiply all the terms together. 3 2s are 6. Root 8 times root 2 is root 16. 2 times 1 is 2. And root 2 times root 2 is root 4. Now we know the square root of 16 is 4, so I get 6 4s are 24. And the square root of 4 is 2. 2 2s are 4. And so I still end up with 6. Yeah, so there's not... Well, the only wrong way of simplifying is if you're simplifying correctly. Similar, okay, I decided to multiply all the terms across at the top. So 3 2s are 6. Root 6 by root 2 is root 12. And then I get 4 times 1, which is 4. And 2 times root 12, or root 2 times root 12 is root 24. So 6 over 4, 2 is a common factor, gives me 3 over 2. And 12 over 24 is 1 over 2, but don't forget they're in square root signs. So if you like, it's the square root of 1 over the square root of 2. And of course, the square root of 1 is 1. So I might leave it as, at this stage, I'd be very comfortable with you leaving your answer as 3 over 2 root 2. Next exercise, we'll see how you could multiply the top and the bottom by root 2 to give me 3 root 2 on the top, and 2 times root 2, which is root 4. So 2 times 2 is 4. So they're the same expression. One just happens to have the irrational symbol in the numerator. The other one has it in the denominator, okay? But either answer is fine.